All right, we can start. I don't know if anybody else will join. So let's start with this problem. Typically, what we do is I'll give you a little bit of time to try to solve it, and then we'll go over it and see if anybody has any questions. So take a look at this geometry problem. I'll give you a little over a minute to try to solve it on your own. Okay, so what I did on this problem was first just draw it out. So we have this triangle ABC. Says AB is 28, AC is 35, and E is the midpoint of AB, and line E is parallel to AC, or line through E, and intersects BC at M. So we have this. So the first thing is we know that E is the midpoint, and since it's already parallel to the third side, that tells us that M is the midpoint as well. Okay. And then a second line through M and parallel to AB, like that, intersects AC at side D. So same idea. If you're going from a midpoint parallel to the third side, then that other side, or sorry, that other point that it intersects has to be the midpoint, which kind of solves the problem for us because it wants the length of AD. So if we know this whole side is 35, then the length of AD is just going to be half of that, which is going to be 35 over 2, or you could say that it's 17.5. Okay, and let's try the other one that was another one that was submitted. So take a look at this one. We got a circle with radius 12 and an intercepted arc. So I'll give you like a minute and a half to try that one. Okay, so this one, whoops, we have a circle, which we don't necessarily, need a visual for, but it might help a little bit. So we have a circle with radius 12. What is the length of the arc intercepted by a central angle? So let's say we had a central angle of 60 degrees, and we want to know the length of this arc. So what they'll give you on the SAT is the formula for the circumference of a circle, which is 2 pi r. But what they don't give you is like the arc length formula. So what we could think of the arc length formula is the arc length is going to be just some fraction of the overall circumference. So it's that fraction is going to be whatever the central angle is over 360 and then times the circumference. So similarly, it's not in this problem, but if you know the area of a circle is given as pi r squared, then I'll say like this is the area of the sector. That's theta over 360 times pi r squared. So these are given on the reference sheet, but these two you have to be able to get. So if they ask you for the arc length, you do theta over 360 times the circumference. And if they ask you for the full area of the sector, then it's theta over 360 times pi r squared. So in this problem, we're just focused on the first one. So the arc length would be 60 over 360 times 2 pi times 12. Obviously, we have calculators for this. So you could just throw all this in a calculator. Um, was I guess this was an open-ended, so we should go over that. So obviously we could simplify this pretty easily, but if you just use a calculator, I'm just going to do that real quick. So 60 divided by 360 times 24 pi. And this is the answer that we would put 12.57 because on all of the free response or the open-ended problems on the SAT, you want to use 5 characters. So if they don't tell you how to round, then you want to do 5 characters. So like the answer that I had in the calculator was 12.566, but I can't fit that many because the decimal counts as a character. So I had to round it to this. So the 6 bumped that up to a 7. The only exception to the 5 characters is if there's a negative, then the negative doesn't count. Then you would have negative and still use 5 characters. But decimals and fraction bars count as characters.
All right, got it.
I have a question. When you're
Yeah.
putting it into like a calculator, is it better to do them all separate?
What do you mean by all separate? Like 60 over 360 first?
Yeah, and then like multiplying that by the 2 times pi and then the 12. Or does
It's
it?
up. Are you using a TI-84?
Yeah.
And I don't think it matters as long as you're using like the previous answer. Like like 60 divided by 360 is 0.166. Like this is what the calculator is giving me. If I were to then round that like that and then multiply by 2 pi times 12, I wouldn't want to do that. But as long as you're like taking this full answer from before by just hitting like times, then it should be fine.
Okay.
Or just you could obviously like you have access to Desmos, you could just put this whole thing into Desmos. Or you could put this whole thing into the TI-84 as well. So if you're going to do it piece by piece, then just make sure you're taking the previous answer
Okay.
and not rounding like each step, because then you'll have a rounding error. Okay, let's try this one. So this one has to do with polynomials. So again, I'll give you. Okay, so a couple different ways to go about this problem. There's again a lot of different ways to attack it, but to go over like the main concepts here. Notice one thing to notice is that there are 3 x-intercepts. And one thing we want to be able to do is just be able to interchange between x-intercepts and the factors that they come from. So the 3 x-intercepts here are -3, 1, and 3. So we should know that -3 would come from the factor x plus 3 and 1 would come from the factor x minus 1, and 3 would come from the factor x minus 3. So first of all, it's really important to just be able to immediately understand that relationship between x-intercepts or zeros and factors. And that's because when we set factors equal to 0, that's the value of x is what gives us the x-intercept or the 0. Um, so that doesn't really help me that much because when I look at the answers, I have x plus 3 and x minus 3 in every answer. Um, so then what I would do to eliminate answers, because I'm going to have to check the other answers by factoring them more. But one thing that can help me do that is if I look at the end behavior. So this is a cubic function that its end behavior is pointing down and then up. That's what happens in a normal cubic function. So I know that it's positive. So that would let me get rid of B and D. So now I'm down to A and C to check answers, which means I only need to check one answer because if that answer is right, then that's the answer. And if that answer is wrong, then it's the other answer. So I'm just going to start with A and I'm going to factor this one further. Well, hopefully we know our factoring. We got X and X. Two numbers that multiply to 3 and add to -4 are -3 and -1. So this tells me that this is the wrong answer because I don't have the factor x plus 3 to give me this x-intercept. So since that's wrong, then C must be the answer. And now, like we would have been done the problem on the SAT, but to just further go over it to see why this works, when you factor this part of it, you get x and x. You also get -3 minus 1, but this one has the factor x plus 3. So it has all 3 factors that we need to give us all 3 x-intercepts. Now, that being said, if you felt like it, I think all those concepts are super important. There's an argument to be said if you really felt like it, you could just start with A, plug it into Desmos, and see if it matches that graph and just make your way through them by just like changing the values a little bit, not like retyping all of them. So there is definitely people that are quick at Desmos that could do this as well in Desmos, but all the concepts I went over are very important as well. So does anybody have any questions on that.
Can you explain how you're able to eliminate the two answers in the beginning because of the end behavior?
Yeah. Okay. So there are four end behaviors. And the way that I think about them is the two most basic functions that we should know on the SAT are y equals x and y equals x squared. So we should just kind of know what these look like. And then based on that, we should also know what y equals negative x looks like. That goes like this. And then y equals negative x squared. It's just an upside down parabola. So if you look at the end behaviors here, this gives us four different end behaviors. There is down, then up. And there's like a mathematical way to go about this, like talking about infinity and all, but I'm just going to say it like this because this is how we would think of it. There's down, then up. There's up, up. There's up, then down. And then there's down, down. And then what happens is we can generalize it to say that anything that's to an odd power like x to the first is going to follow these end behaviors. And anything that's to an even power, so x squared, x to the fourth, x to the sixth, and so on, is going to follow these end behaviors. And the fact that this has three x intercepts, or if you just look how, if you were to multiply each of these out, you would end up with like an x cubed. So that's how I knew it was x cubed. X cubed is going to follow what x to the first does. And a fact that it's down then up, like this one, tells me that it's going to be positive. So the value in front has to be a positive. So I just get rid of the two negative one thirds.
All right, got it.
Okay.
But again, if we understand that, it takes me a lot longer to explain it. But if we look at a problem like this and we can say, okay, the end behavior is down then up, so has to be a positive. Um, that just gets rid of these immediately, and then we just start factoring and matching our intercepts. Or like I said, you do have the option of using Desmos, which we will on some problems, but problems like this, I like to go over the concepts as well. Okay. All right. Let's try another one. This one has to do with exponential functions. Okay. This one is difficult based on just the wording. There is kind of a quick way to do it, but I want to go over it first. So they like to say this a lot. Which of the following equivalent forms shows the value of n as the coefficient or the base? So if you just look at exponential functions in general, or a b to the x, whoops, it should be to the x. So the a here is what we would call the coefficient, and the b is the base. So what they want is when we substitute in 3, we're going to get a value, and that value is n. And then that value needs to also be in the position of either a or b. So kind of the longer way to do this would be to just run through all the answers. So I'm going to do it that way first. So to really see why some of the answers are just clearly wrong. And I don't need a calculator for this. I'm going to just write it like this. So this one, h of 3 would be 45 times 2 to the sixth. So whatever, I could use a calculator to figure that out, but whatever 45 times 2 to the sixth is, we would need that huge number to either be A or B. And clearly it's not. A is 45 and B is 2. So this answer is wrong. Here, h of 3 would be 70 times 2 to the third, which again, that's not too hard. That's 70 times 8, which is 560. We really don't have to find that, though, because clearly 560 is not one of these numbers. Then when we look at this one, h of 3 is 105 times 2 to the 3 minus 1 is 2. But again, whatever 105 times 4 is not 105 or 2. So the answer has to be D. And to see why this is, we'll talk about in general why we could have probably skipped right to that answer. H of 3 is 140 times 2. Well, 3 minus 3 is 0, and anything to the 0 is 1. So we get 140. So 140 is the value of n, and it is also the coefficient. So what ends up happening is when you substitute in a number, the only way you're going to get the coefficient specifically is if the exponent is 0. So we could have just looked ahead and been like, well, which one when I plug in 3 is just going to give me an exponent of 0, and that's going to be this one. Because you can see these ones have no chance of being the answer. They almost seem kind of ridiculous. And so it's the only way it's going to work is if you have an exponent of 0. That'll give you this value. And that's the only way that when you plug in a number, you're going to get the coefficient. So questions on that?
No.
No questions. I think it makes sense.
Okay, good. Yeah, it's kind of a weird problem. But they like to ask that in these types or like quadratics. And when all they want to know is whatever you get for this answer, it needs to basically show up in the problem. And this is the only one where you get an answer that's actually part of the equation. Okay. Here we've got we're going to do both of these problems, 5 and 6. I put these together because they are examples of when we probably should use Desmos versus when I don't think we should. So again, I'll give you a little bit of time to take a look at number 5. Okay, so here is one where it feels like we should use Desmos. The only issue I have with that, and we could try it with Desmos, is that when we have a value that's unknown, this is where you would want to use like a Desmos slider. The issue is that there's no answer choices. So you have to like play around with the slider. So it really kind of depends on what the answer is. If the answer ends up being like 5, then we probably would find it using Desmos. But if the answer is like negative 2.7, then we would be unlikely to find that using Desmos. So not knowing that going in, I would rather have another way to solve it. So that's why I want to go over that way here. So what we have is this is a system. Well, the easiest way to solve this system is to just set them equal to each other. So I have x plus k equals x squared plus 3x minus 8. Then I say to myself, I have a quadratic. The way I solve a quadratic typically is I would want it to equal 0. So I'm going to bring this x over to this side. So if I take an x away, I'm going to get 2x. And then I'm going to move the k over to this side. So I just have negative 8 minus k. So now I have a quadratic. And this has to do with the types of solutions to a quadratic, because I want there to be no real solutions. So this is related to something called the discriminant. Whoops. That is the b squared minus 4ac part. That's the part that's under the square root in the quadratic formula. And when that is less than 0, we have no real solutions, because that would mean in the quadratic formula, we would be taking the square root of a negative, which is not real. So this is what we want to happen. So I'm just going to do that. So b is 2. So 2 squared is 4. Minus 4 times a is 1 times c. This is where the tricky part comes in. C is the entire constant. It's negative 8 minus k. And I need all that to be less than 0. So we're going to just do a little bit of algebra here. So I have, this is negative 4. That's going to get distributed to here. So that gives me plus 32. And then plus 4k. And then I want to get k by itself. So I'm just going to do a couple things in my head. 4 plus 32 is 36. And if I bring it to the other side, that's negative 36. And finally, I'm going to go over here. If I divide each side by 4, k is less than negative 9. So that's what the discriminant tells me, that as long as k is less than negative 9, I will have no solution. So the largest integer that it could be is actually -10 because it has to be an integer. It can't be -9 because it has to be less than -9. So the largest integer that's less than -9 is -10. So again, we could have used Desmos and plugged these in and saw where there was no intersection point, but we would have had to figure out that like -10 was the largest value of K. So I feel like that would be much more complicated. And it would be better to know in these cases how the discriminant kind of helps you decide how many solutions there are to a quadratic. All right, try this one. This is a similar one, but this is one where I would use Desmos, but I'll give you a little bit of time to try that. Okay. So here's one. I kind of usually operate under the general rule of if, again, we have some constant where we want something to happen based off of that constant, and we have a multiple choice, those are the types of problems where I just like to do in Desmos. So I want to go over that way because you can see that the discriminant way takes a bit of time. So I would want to, avoid that. So let me just jump over to Desmos. All right, so what I'm going to do is I'm going to just put in the first equation, which was y equals, it was -2x squared plus 10x minus k. And it's going to ask me to add a slider, and I'm going to. And then I'm going to put in y equals 15. I'm going to zoom out a bit. And the question said wanted there to be one intersection point. So I'm just going to test my answers because now I have one's a test. I don't have to like play around with it. I can just go in directly. So the first answer choice was -5/2, which looks like the answer because it intersects once. But if you want to double check, just try the other answers. So another answer was -15/2, which clearly is wrong because it intersects twice. The other one I think was that 35/2. Whoops. What am I doing? Which is again none. And then I think it was 55/2, which is again none. All right, so -5/2, I'll go back to that one, is the one that intersects at once. So the answer choice is A. Okay, here's another good one for Desmos, but again, take a look at it, and but you have to know a couple things before you can use Desmos, but there is a very quick way to use Desmos here. But I'll give you, again, a little bit of time to try it. All right. So before we worry about using Desmos, so we can't go directly to Desmos and recreate this diagram because we don't know either of the equations. But what we have to know about the parabola is that parabolas are symmetrical. So we know this is the origin. So we know that's an x coordinate of 0. And then it says that it intersects this point P, like is the vertex. So that means that this x coordinate is 4. And it must be halfway because it's symmetrical. So that would mean this x-intercept is 8. So that tells me that just that knowledge of the quadratic tells me that this line goes through the point 4, 6 and 8, 0. And what it wants is like g of x is the line. It wants g of 0. Well, again, hopefully we know that g of 0 is just a fancy way of saying, well, what's the y-intercept? Because when I plug in 0, what am I going to get? That's where the line is going to cross the y-axis. All right, so this is where I would hop over to Desmos. You can certainly do this by hand, but I just want to show you like a really quick way to use Desmos. So we're going to use those 2 points. So anytime you have 2 points on a line, you can do this. You can add a table and then put those 2 points in. So I'm going to do 4, 6, and 8, 0. And then you just hit this button here, which is add regression. The default is going to be linear regression, which is what we want because we know it's a line. And this tells me the equation right here. And this right here tells me that the y-intercept is 12 if we understand like y equals mx plus b and b is 12. And if you forget that, you just go up here and you just see it crosses at 0, 12. So the value of g of 0, and even if that didn't make sense completely, you could just say g of x equals negative 1.5 x plus 12, and you could actually do g of 0 and still get 12. So a bunch of different ways, but the more that you can understand it, the concepts of it, the quicker you can kind of be with using Desmos and then just like in getting the answer really quickly from Desmos. Okay. This is a pretty tough one, so I'll give you the time for this one. Okay. This one is pretty challenging because of just all of the variables. So one way that I like to attack these is to just choose my own values. So I have M, R, and K. So it doesn't really matter that it represents the problem. Like it doesn't have to be an actual like rent. I don't really care about that. I'm just going to pick some numbers that are pretty easy to work with. So what I did was I chose the rent first and I just made that 24. I don't like, I kind of just made that up, but not exactly. And then I decided that there was going to be 6 members because I wanted it to divide into that. And then I wanted to pick just a nice, easy number of people who failed to pay. And I just made that 2. You do not have to pick these values. They're just values that I picked. So then what you do is you just figure it out based on your values. That should be a little easier than trying to figure it out without numbers. So now when I read the problem, if um if you have R dollars equally among the M members, that just means if you have $24, if something costs $24 and you're splitting it among 6 people, then each person should pay $4. So I just kind of remember that number, right? Now, if 2 less people decide to pay, now you have of the 6 members, only 4 of them are paying. So now 24 divided by 4 is 6. So then they would each pay $6. And it says then how much additional would they have to pay? Well, the additional that they would have to pay in my example is $2. So what this means is when I plug in these numbers, the answer that gives me 2 is going to be the answer. And then you just got to kind of run through them. So this is like 24 divided by 6 minus 2. Well, that's not 2. K times R. This is 48 divided by 4. That's not 2. This one is KR. So this is 48 times 4 divided by 6. That's not going to be 2, but this one's going to work. K times R is 48. M is 6. M minus K is 4. And 48 divided by 24 is 2. So you choose your own values that you can work with easily, get the answer, then plug those values into each answer choice, and then just see which one matches the same value that you got. So if you pick different values than me, you would be looking for a different answer, but we would all end up at answer choice D. All right, we're going to do just a few more. So try number 9. Okay. So I'm going to actually do this both ways. So the first way I'm going to do it is just using Desmos. So the key to using Desmos is what we talked about earlier, is that when you see a factor, we have to just automatically know that x plus 1 means an x-intercept of -1. Right? So we've got to just like see them. And then let me just write down the answer choices. So then we're just going to go over to Desmos. So you're going to go to Desmos. And just put in the polynomial. So x to the 4th minus 3x cubed minus ax plus a. Now I'm going to add a slider for a, and I'm just going to check the answer choices. But again, it's not helpful if I don't know what I'm looking for. And what I'm looking for is the answer choice that has an x-intercept at -1, which would then have a factor of x plus 1. So my first answer choice was 4. So I just type in 4, and I don't see an x-intercept of -1, so that's wrong. So then I type in 2, and that looks wrong. And then I type in -2, and that looks right. So that's got to be the answer. But if you want to be sure, type in -4, and that does not cross that -1. So again, the answer is -2. We could have stopped there. I didn't have to check the last one. So that is one way to do this, is to just say, I'm going to graph it and see which answer choice gives me an x-intercept of -1. So first, any questions doing it that way?
No.
Yeah, no questions here.
Okay. So then I just want to show you another way that's maybe equally as fast. I don't know, but it's definitely close. And it could just depend. So if I know that -1, 0 is the x-intercept, which I need to realize that anyway to use Desmos, what that means is if I plug in -1 for x, that has to equal 0. So this way just depends on how quickly you can do math. This is just 1. This is -1 times -3, so +3. This is plus a, and then I get 4 plus 2a equals 0. And then I get 2a equals -4, and then I can see that a is -2. Right? So either way, whether you do it by hand or you use Desmos, like you can't get around the fact that you have to understand that something being a factor means that it's an x-intercept, which means doing it by hand, when you plug in the x-intercept, the specific numerical x value, you're going to get 0 as the output. So you can use that way to solve for a as well. So it becomes kind of whatever one you want to do. I have one more problem here. So let's take a look at number 10. Okay. All right. I'm going to do this one two different ways. So again, first way is I'm going to use Desmos. So the thing about Desmos is this is going to be like solving a system of like systems of equations. The problem has C's and D's in it, but I need to use X's and Y's. So I'm going to rewrite it like this. So I have 9 to the X plus Y. Whoops, not like that. I got to use parentheses. All right, so that's equal to 27. And then the other one is going to be 4 to the X minus Y equals 16. And then I'm looking for the intersection point. This is the issue. It's not giving it to me. And I don't know why. Usually when you click on it, but maybe because it's like an exponential function. This is the weird thing too. Like sometimes Desmos just doesn't. But if we were to kind of look, this looks like it would be like 1.75. So let's see. It'd be like, so already this is probably not the best way to do it. And this would be like 0.25. Oh, negative, my bad. That looks right. Okay. So then it wants c squared minus d squared. So I do 1.75 squared minus negative 0.25 squared. And I would get 3, which is the answer. So first of all, do we have any questions on that?
No.
Okay.
Yeah, no questions.
Yeah, but this is why like sometimes like you try to use Desmos and it doesn't go the way that you want because of like all the decimals and the fact that since it was an exponential equation, it just didn't allow me to like just click on that and I had to kind of like figure it out. So then the last thing I want to do here is just go over the other way to do it. So this is why you can't always rely on Desmos, like you need to know other ways to do it. So kind of like the quick way to do this is when you look at this equation, I want them both to be powers of 3. So 9 is 3 squared. So I could think of this as not 3 to the 2 times c plus d equals 27. Or I could even go further than that. I'm going to need to do this thinking anyway. I could think of 27 as just 3 to the third power. So therefore, 2c plus 2d has to equal 3. And then if I look at the other one, well, this one's a little easier. 4 to the c minus d. 16 is just 4 squared. So c minus d is equal to 2. This equation, I'm just going to divide by 2. So I get 3 over 2. And then kind of the trick here is to realize that c squared minus d squared is c plus d times c minus d. And c plus d is 3 over 2. And c minus d is 2. When I multiply them, I also get 3. So by hand, I get 3 as well. Obviously, that's the answer. So in Desmos, it gets kind of a little strange. You got to be able like to adjust, or you could try to do it a way like this by hand.
Okay.
All right, got it.
We're good with that?
Mhm.
Okay. All right, then that'll be our last one tonight. So thanks for coming, and I'll just see you. We'll be doing the same time next Monday.
Okay.
All right,
Thank you.
then. See you next week.
All right, bye.
Bye.